Hi class, this is Professor Smith. I'll be doing number 6 on the sample test 2. Alcohol withdrawal occurs when a person who uses alcohol excessively suddenly stops the alcohol use. Studies have shown that the onset of withdrawal is experienced a mean of 40 hours after the last drink, with a standard deviation of 19. A sample of 36 people who use alcohol excessively is taken. What's the probability that the sample mean time between the last drink and the onset of withdrawal will be 38.5 hours or more? In this problem, we need some clues to let us know what type of problem this is and how we're to approach it. The fact that they tell us the mean hours in the second sentence of 40 hours and also the standard deviation of 19. Then they say something that's different. In the other problems, they say, and it was normally distributed. But in this one, it doesn't. It just tells us that the sample is of 36 people. We know by the central limit theorem that when the sample size n, in this case 36, is larger than 30, we know that the distribution of the sample means is normal. So this is our clue that this is going to be a problem on central limit theorem sample means. Let's go ahead and write down the information that they give us, capture that in math type, and begin the process of solving this problem. So we have a mean of 40, and that can be translated into mu equal to 40 for the population mean. We have a standard deviation of 19. Again, this isn't based on a sample, so that would be the population standard deviation denoted by sigma. That's the lowercase Greek letter, sigma. And then the sample size of 19, that lets us know that n is equal to 36. In our problem, they want to know, let's find our problem. What's the probability that the sample mean, and again, that's another clue that it's the central limit theorem for sample means, that the sample mean time between the last drink and the onset of the withdrawal will be 38.5 hours or more. So we want to find the probability that the sample means will be 38.5 hours or more. And the symbol for sample mean, do I have that one on here already? I don't believe I do. So we have x. If it's a sample mean, it's x bar. And I'll save this to my itinerary so I don't have to pull it up again. Is 38.5 or more. 38.5 or more means that it could be equal to 38.5. That's what the is represents, or more is greater than. So we can rewrite this as the probability that the sample mean is greater than or equal to 38.5. The first thing we want to do is find the z-score that corresponds to 38.5. And you said, well, how do you know that it's going to be a z-score? Because by the central limit theorem, we know that the sampling distribution is normally distributed when n is greater than 30, and 36 is definitely bigger than 30. So we're going to find the z-score that corresponds to x bar of 38.5. And the formula for converting a z-score, pardon me, for finding a z-score given us a normal score is given by z equal, and the z-score is given by x bar minus mu all over sigma over the square root of n. X bar, I said, well, where do we get that? Well, we want to know the probability that it's greater than or equal to 38.5, so we substitute in that 38.5 minus mu, which was 40 over 19, divided by the square root of n. And in our case, n is equal to 36. We'll go out to the ALEKS calculator and do that computation. So we have 38.5 minus 40 all over 19 divided by the square root of 36. And we get a z-score of negative 0.4736, or 37 if you round your intermediate computation to, intermediate is to 4. So we'll round that to 4 places. So it's negative 0.4737. We want to find the probability that p of x is greater than or equal to 38.5, which is the same as finding the probability that z is greater than 0.4737. Notice here we have x bar, in the next equation z. We have greater than or equal to. Here we have greater than or equal to. Here we have x bar of 38.5, and here we have the corresponding z-score of 0.4737. We'll go out to the ALEKS calculator to do that, and when we do, we'll notice the inequality symbol is reversed. It's less than or equal to. So anytime that inequality symbol is reversed, we have to use the complement. So it's going to be 1 minus the probability, not z greater than or equal to 0.4737, but less than or equal to. So let's change that symbol to less than or equal to. Now we'll go out to the ALEKS calculator and do the computation. We'll double click on our value there. We'll hit P of Z because we want to find that probability, and then 1 minus. And that gives us 0.68217, and they tell us to round our answer to 3 decimal places, so 0.682. So I hope this movie on number 6 for sample test 2 on the central limit theorem sample means was helpful for you.